Yeah. Yeah, my slide is visible. Hello.
Yes, sir. Yeah.
Yeah. Yeah, in today's class, we have to understand the emergency of high-speed LANs. To know about emergency of high-speed LAN, we have to understand that why high-speed LANs are required. I have summarized a few points based on that. Okay, I'll just go through all the points whatever I have summarized here. Because nowadays the entire communication is going to happen with the help of better network connectivity. Hence most of your office lands are designed based on good connectivity. Okay, that's one point. Providing a work group connectivity at a department level, in the sense that you go to any department or working place, you will have local area network design for the connectivity purpose. Next is traffic patterns light, where more importance given for file transfer and electronic mail communication using your network connectivity. Then more powerful platforms support graphic intensive applications. Once you use, there will be more and more graphics applications. If you have low speed data communication devices, it may not be possible to have, there will be a better clarity. Hence high speed LANs are very essential. Then connecting PCs and terminal to mainframes and mid-range systems that can incorporate applications, because we are moving from very low end personal computers to there will be high end personal computers, including your smartphones, laptops and other devices. Hence very high end local area networks connectivity is very essential. Having said right now, you should also think about always what we were using earlier, and what is our current applications. Then how do we move on to the next level connectivity and the data transfer speed of your devices. Okay, by considering all these aspects, speed and power of PCs has risen drastically. Hence you cannot have the same kind of data transfer rate or same kind of LAN setup wherever you are trying to design it. Okay, that's one point. Then MIS organization recognize LANs as essential. That is an not only MIS, it may be an your MIS as well as large scale integration organizations as well, because we are moving from very small scale organization to medium scale, large scale, and even enterprise organizations. Okay, and everybody required there will be a network connectivity. Hence we need to think about there will be high speed LANs. Yeah, wherein you also think about client and server computing operations, then graphic intensive applications and graphic user interface applications as well, because more and more client server interactions are happening across the globe, either to place your data into specified servers, or you may able to retrieve your data whatever you require from the specified servers. Yeah, now dominant architecture in business environment as well, right? Uh, because the present kind of systems uses, there will be a very high-end architecture design, okay, where according to the development of architecture, we need to have, there will be an right better data transfer rate from our end also, with respect to right local area network. Yeah, then intra networks, we are trying to use, there will be an intra networks for our own applications, because uh, even though we use, there will be an internet applications more and more, but sometimes you want to work with your own applications, you may look for, there will be an internet intranet right applications as well. Hence high speed local area networks are essential. Then frequent transfer of large volumes of data. I think all of you will agree with this point, okay? Because more and more, right, data is generating at every hook and corner of your room, or office place, right? Wherever you are, right? So then the data is going to become, there will be huge. The data you want to be place it. Hence, high speed LANs are very essential. Then we have nowadays centralized server farms, right? And you name anything nowadays, we are thinking about centralized servers. I was talking about earlier also, different kinds of, there'll be in servers, maybe based on the functionality, we are trying to have different types of, there'll be in server where the client is going to interact to retrieve the data and for further processing. Then user needs to draw huge amounts of data from multiple centralized servers, right? That is one simple right application relating to a color publishing here, right? You name different applications related to that. I think it may be a web server, or maybe a file server, maybe a print server, right? Or job pooling server, right? Lot of applications you can write it over here. Then servers contains tens of gigabytes of image data, right? So download it to imaging workstation is needed, in the sense that, let us say, right, unless you don't have, there will be an good infrastructure at your end, or maybe wherever we have the network connectivity, it may not be possible to very easily upload or download the amount of data what you want to right fetch, or what you want to place it. And also, right, many power work groups are available across the globe, right? Everybody wanted to work on their domains, and want to place the data and want to interact with intranet or internet right services. Hence, you require, there be very high speed local area networks. Yeah, small number of cooperating users. Then draw massive data files across networks, right? So to talk about that, we have a software development group testing new software versions of computer-aided design, running simulations, because once any development process is going on, right, with respect to different applications, right, uh, many engineering right groups may be working with different domains. Hence, a lot of sharing of data files may be required with one another. Okay, unless until you don't have, there will be a good setup with you, right? It may not be possible to do, there will be a better communication. Then we have, there is an high speed local backbone right requirement as well, because so as I was mentioning about the necessity of, there is an high speed local area networks, and at the same time as and when more and more number of networks have been designed, maybe in the campus or maybe in the organizations. Hence, we need to have that be a very high speed, backbone network in your places, right? Hence, you don't have any glitches during your communication from end to end. Yeah, even though whatever presently with very good infrastructure, but right, everybody started using right, computers and internet applications extensively, locally as well as across the globe, right? Hence, the complexity of the data is going to become huge. Once the complexity of the data is huge, what will happen, right? However, the infrastructure you may have it at your end, that infrastructure may not be right, cope up very well for a certain period of time. Hence, you need to upgrade all the time, right, based on the requirement of the user as well. Hence, high speed local area networks are very essential during the present day context of data communication from end to end devices. I think this is the one simple understanding about why high-speed local area networks are essential, and this is also an emergency of high-speed local area networks. Okay, you can write a lot of points related to this particular topic, right, with respect to applications, with respect to technology, with respect to architecture, with respect to your internet, intranet. Then you can also think about with respect to various groups coming together, right, working with different domains as well. Yeah, do you have any questions here? You can ask me. Hello. Yeah. Do you have any questions?
No, sir.
Okay, fine. Let's move on to the next right topic, that is a range of technologies with respect to right, designing of local area networks. Yeah, as and when we go ahead with various, or different types of technologies, what we use to design your local area network. Okay, we may think about some. I mean, these are all some of the technologies that is in fast and gigabit Ethernet, right? Even somewhere we can see there will be an Ethernet itself, but the Ethernet switched on to there will be in fast Ethernet, right? Then fiber channel, technologies. What we have high-speed wireless local area networks. Okay, it's not necessary that there will be a wide technology. We can also look for high-speed wireless local area networks. Then carrier sense multiple access with collision detection, technique. That's what in a short form you can call. That's in CSMA, right? Where we come across two major kind of there'll be in protocols. One is CSMA CD, and another one is in CSMA, right, CA. That's in collision avoidance as well. And also we have Xerox. There is an Ethernet. Okay, earlier it was using, but nowadays we moved on to there will be an right fast and gigabit Ethernet. Then we have variants of different variants of IEEE 802.3. Okay, you can also understand some of the aspects of 802.3, 802.4, and 802.5. Then we can look for there will be a random access right design aspects as well. Then stations access medium randomly. contention, then stations content for time on medium. I mean, all these random access, stations access medium randomly, contention, station content for time on medium comes under the LBN IEEE 802.3. So what I'm trying to convey here is that, when you go ahead with designing of your local area network, you can look for different technology as well as the different protocols, right, to handle your data transfer, right, from one end device to another end device. Yeah. Uh, Let us understand some of the right now. You know, what is that? Protocols or right collision techniques. Whatever we use it. One we call, there will be an Aloha, where Aloha is a packet radio kind of a form, where one station has a frame, then it going to sense the data, and then station is going to listen, right, plus small increment of time. So if acknowledgement is fine, right, then the data transmission is going to happen. If not, the data is going to be retransmitted. If no acknowledgement after repeated transmissions, then it's going to right, give up that particular kind of process of operation. And basically, Aloha is going to work on with a frame check sequence with the help of SDLC, right, protocol. If frame okay and address matches receivers, then it sends as well as it receives. There will be the acknowledgement. Frame may be damaged by noise or by another station transmitting at the same time. That is what we are trying to say. Collisions may occur during these kinds of data communication. Yeah, any overlap of frames causes there will be a collision during your data communication from one end device to another end device. But the utilization of your available resources in case of follower technique is not very good. The maximum utilization is only 18%. Yeah, this is what is a simple, pictorial representation to understand, right, Aloha, right, design where, right, number of stations are connected to a base station, right. Each station can transmit the data provided if there won't be any, right. I mean, if the frame is ready, okay. So if all of them trying to, send the frames at a time, definitely there is a collision is going to occur it. Yeah, hence, right now, in order to avoid, right, the collision, then we moved on to, there will be in slotted Aloha, where in, right, here time is going to be, right, use for your data transmission, right, time is going to be uniform slots equal to frame transmission time. Needs a central clock as well here. A transmission begins at slot boundary. Frames either miss or it may overlap totally, right? If you compare right, slotted Aloha with Aloha technique, what will happen? So since right, uniform time slots are given for each frame, obviously the link utilization here improved, right, to the 37%. However, the available shared resources are not going to be utilized extensively. A lot of resources are unused in this particular case also. Yeah, this is what is a simple illustration to understand, right, slotted Aloha, right. You have n number of slots here, right, starting from the Libyan slot 1, slot 2, it goes on up to the Libyan n slot, right. No, each station can transmit a data, right. However, the time slots are available, but right, once the stations or there is an clients are started sending its frames with the same time slot as well, then what will happen? It leads to the Libyan collision also. Okay. However, uh, you can improve compared to the will be in slotted, I mean, Aloha technique to the will be in slotted Aloha, right, network. Yeah. If you look at some of the differences between pure Aloha and there is in slotted Aloha, you can have right now these points here. Yeah, in case of there is a pure Aloha, any station can transmit the data at any time. Okay. On the other hand, any station can transmit the data at the beginning of any time slot. Okay, that's the point. And the time is continuous and not globally synchronized in case of Aloha. On the other hand, right, the time is discrete and globally synchronized. And the next point is probability of successful transmission of data packet is right now g into e to the power of minus 2g. Here also the probability of successful transmission of data packet is g into e to the power of minus g. Then the maximum efficiency is 18.14%. I mean, roughly it is on that. It is, as I was said, it is on 17%. Okay, you can say the efficiency is 18.4% here, and this is efficiency is 36.80%. Okay, these are all some of the differences which you can mention about Aloha versus the slotted Aloha. Yeah, however, your resources are not going to be utilized more extensively. Then you can also think about the another important protocol which you have come across already. That is what is your CSMA, right now, carrier sense multiple access. Yeah, what's going to happen here? Right. In CSMA, propagation time is much less than there'll be in transmission time. Okay, that's the very important point you have to note. Yeah. Then all stations know that the transmission has started almost immediately. But what happens in CSMA is that first it listens for clear medium. Okay, if the medium is clear, then only the transmission is going to happen. Station is going to transmit. Otherwise, it's not going to happen. If two stations start at the same instant, obviously the collision is going to occur here also. Then we have to wait reasonable time here. That's where we use the round trip time to resolve that. If no acknowledgement, then you have to retransmit. The maximum utilization depends on the propagation time and frame length as well, because we don't know, what may be the propagation delay time required for your data communication from one end device to the another end device. It all depends upon there will be the size of your local area network. A longer frame and shorter propagation gives there will be a better utilization, because what happens, if the propagation time is going to become, there will be more and more, obviously, the data is in the transit mode, hence the collision occurring in a local area network may be very less. Yeah, this is what is a simple illustration to understand about your CSMA, I think goal is here to reduce the wastage of bandwidth due to the packet collisions. So principle is sensing the channel before transmitting. Okay. While doing that, you are going to come across two kinds of protocol. One is CSMA bar CD, that is in collision detection, and the another one is in collision avoidance. Okay. And also you have the property called as there is a persistency while in sensing and transmitting as well. Yeah, you can observe it from this diagram. What happens here? Station A begins a transmission at time 0. Okay, there won't be any collision. First, it is going to sense and it is going to transmit. Okay. Station A captures the channel at T propagation delay time in the second diagram. If you look at the whole procedure in case of data transmission between end-to-end device, you can understand the flow of information from this particular flow chart, right? A very simple illustration, right? The first is you have to check whether the frame is ready to send. If it is yes, then you have to check it out whether the medium is idle or not. If it is yes, certainly you can transmit, right? While listening. In case if it is the medium is busy, obviously you have to restart the process. Okay. In case, right, if the transmission while listening, a collision is detected, obviously you have to stop transmission, transmit the jump signals, and you have to right wait random time, because random time backup algorithm is needed to resolve the issue. If there won't be any collision, obviously the transmission is going to happen, in the sense that, right, first you have to check whether the medium is idle. That's one condition. Yes, it is idle, then you can transmit. Okay. While transmitting, if the collision detected, how you are going to handle the situation, you have to look for it. Okay. Otherwise you have to transmit the data. Yeah. When you go ahead with CSMA, right, there are three types of CSMA protocols. You can look for it. One is one persistent CMA. Then the second one is non-persistent CMA, and the third one is P-persistent CMA. Right? I have a few points on these three protocols. I think you have already come across these things. Again, you need to recap all these kinds of the LBN protocols, because as and when you started using with respect to local area networks, right, with the different technologies, these things are very essential. Hence, recapping or reviewing of all these things, right, is very much required here. When we go ahead with one persistent CSMA, a node having data to send starts sending if the channel is sense free. If the medium is busy, the node continues to monitor until the channel is idle, then it starts sending data. In case of non-persistent CSMA, if the channel is sense free, the node starts sending the packet. Otherwise, the node waits for a random amount of time and then monitors the channel. Okay. Whereas in case of P-persistent CSMA, if the channel is free, a node starts sending the packet. Otherwise, the node continues to monitor until the channel is free, and then it sends with a probability, a P. So that is the reason we call there will be in here, there will be in P-persistent CSMA, right? Yeah, I'm just having some more points here to talk more in detail. I think I'm going to share all these things with you. Okay, you can refer these things, right? Non-persistent CMA, one persistent CSMA, and P persistent CSMA as well. Okay, and also P persistence, there will be in CSMA. Yeah, let us move on to the next protocol here, that is in CSMA bar CD. You know that, okay? Whenever the collision which occurs during your data transmission, then that's going to be detected using this particular protocol, especially in case of the LBN wide network. Yeah, with CSMA, collision occupies a medium for duration of transmission. Stations listens while transmitting the data. If medium is idle, then the transmission is going to happen. Otherwise, it will go to the step 2. If busy, then it listen for there will be an ideal, then it is going to transmit. If collision is detected, jam then cease the transmission. After jam, wait random time, then start from there will be the step 1. I think you can follow that flowchart, whatever I have already shared with you right in the previous slide. Yeah, this is the another illustration to talk about your CSMA bars CD operation. Okay, I think you can take as many number of stations to illustrate your CSMA bar CD operation. Okay, you can just talk about when you start sending the frames at time t0, what's going to happen it. Okay, so then similarly at time t1, what's going to happen it. Then at time t2, what's going to happen it. Okay, and time t3, what's going to happen it. If there is any collisions, right, uh, initially there won't be any collisions, but as and when the number of stations okay trying to send, there will be the data from its end. Obviously the collision is going to occur, okay, during there will be an subsequent time intervals. Okay, the reason is that initially the medium is idle, then the data transmission happen without any issues. But as and when every station starts sending it, even though they sense that it is an ideal initially, but due to the propagation delay time and other network issues, there may be collision which are going to occur it. Right, these things are going to be handled by your CSMA bar CD operation with what is that protocol to be called as random time backup. There will be an algorithm. Yeah, so you have to understand that, right, why persistence algorithms are required. Okay, unless you don't have the Boolean persistence algorithm, right, what will happen, the available data transmission may not reach to the end devices. That's one point. And the second point is there will be more and more collisions may happen it. Okay, and all the time to come out of this, you can think about what do you call, there will be an backup algorithm, a random backup algorithm, right, with incremental time factors. Yeah, you can call that is a binary exponential backup algorithm here. I think you know that what's going to happen it, right, in case of binary exponential backup algorithm. Yeah, I'll just go through these points here. Attempt to transmit repeatedly if repeated collisions occur during data transmissions. First 10 attempts, it means that value of a random delay is going to be doubled. Value then remains same for 6 further attempts. After 16 unsuccessful attempts, station gives up and reports there will be an error. Right. As congestion increases, stations back up by larger amounts to reduce the probability of collision. Right. That's one thing. Yeah, one persistent algorithm with binary exponential backup efficient over wide range of loads. Low loads, right? One persistence guarantees station can cease channel once it is an idle. High loads at least has as stable as other techniques. A backup algorithm gives last in first out right effect. Stations with few collisions transmit their bin first. So what I mean is, right, you can always look for some of the insights of binary exponential backup algorithm, as in when you started using CSMA bar CD protocol to handle the bin collision detection technique. Having said those points, you can also look for based on different kinds of buses here. We talk about on baseband bus, collision produces much higher signal voltage than there will be the signal. Collision is going to be detected if the cable signal greater than there will be the signal station signal. Then signal is attenuated over a distance. A limited distance is going to become, there will be an 500 meters. You can also say that is an 10 base 5. Always you can multiply that with 50 here. There will be an then or 200 meters. There will be an 10 base that is an 5 into there will be an 100 here. That is an here. That is an 2 into there will be an 100. Okay, so that is how we are going to calculate, say that's 500 meters in both the cases. Then for twisted pair activity and activity on more than one port is going to be right now. One port is a collision. A special collision presence right present signal is right detected in case of there will be a collision detection. What I mean is right, as and when you make use of a different baseband, different right you know cabling conventions you can think about in case with respect to different right now transmission medium. Yeah, let us understand some of the differences between CSMA bar CD versus CSMA bar CA here, right? Look at this. CSMA bar CD, it is for wire communication basically. No control before there will be the transmission. It is possible only once the operation is started. Then it generates there will be collisions. Yeah, and also it is going to detect there will be the collision, and it is going to handle those collisions with the help of your exponential backup algorithm. When it comes to the CSMA bar, that is in CA, collision avoidance. So it is for there will be a wireless communication. Then collision avoidance, happens before that will be the transmission itself. Okay, and you need to think over how we can easily avoid there will be a collision in case there will be a wireless network. Yeah, difference in energy as well, power for transmit and receiving stations. Difficult to distinguish between incoming weak signals, right, or noise and effects of its own transmission as well, right? So you can always write a lot of differences between CSMA bar CD as well as there'll be in CA. While writing your answers, you can always write there'll be an one network topology by making use of right various number of stations, and you can explain it in detail with respect to your high speed local area network. So the whole idea is that as and when you want to design your high speed local area networks, you can make use of these protocols for your working operations, and right, if there is any collisions occur during your data transmissions, right, how these protocols are going to be used to handle right, as well as to ensure the data is going to be reached to the other end of your devices. Yeah, do you have any questions? You can ask me, right? If not, we can move on to the next right point. Yeah, do you have any questions here? Hello? Hello?
Yes, sir.
Do you have any
No, sir.
questions? Yeah. Yeah, let us move on to the other variants of right. Yeah. Just go ahead. Yeah, that's an IEEE 802.3 frame format. I think you have already come across this, right? As I mentioned that you have a different IEEE, versions, maybe an 802.3, 802.4, and 802.5. This is the 802.3 frame format structure, which includes preamble, right? Then start of frame delimiter, destination address, source address, length, LLC. Okay, that is your payload basically, and you have FCS. There is a frame check sequence. I think you already come across it. I mean, the whole idea is that you must aware of it. The different technologies you use during right designing your high-speed local area networks at your end, or maybe the different technologies which may be required to work on with high-speed local area network. Yeah, I mean, to understand some of the right technology requirement in terms of the bin hardware here, right? We have different, Ethernet cables which cope up with there will be 10 Mbps data speed, where you can identify these cables with cat 3, cat 5, cat 5e, cat 6, and there'll be in cat 7, and so on. Right, nowadays we use there'll be in cat 7 cables, and however once you visit right different departments and workstations, you may look for there'll be different cables as well. You can easily notice that by observing right the cable whether it belongs to the cat 3, cat 5, because you have a captions on each cable as well. And also you are going to connect uh, right to your system right, or your node, using there'll be an RJ45 connectors. Yeah, this is what is your RJ45 connectors basically. Okay, you can look at this, right? Probably once you're connecting right your devices to the local area network, right? I think definitely right, you might have come across there'll be an I mean these kinds of there'll be an connectors. Yeah, this is what is the simple right local area network wherein you can connect with external world, also using your internet services. I mean, it's left to you how you're going to design your local area network at your end. You can look at this right on the right hand side. You have there will be an wireless network, and on the other hand side, that is at the bottom, you have one wide network. You can have, there will be the different ether network, local area network design setup. Okay, and ultimately all your local area networks are connected to internet application via there will be an, your router. Yeah, your ethernet, right, 10 mbps ethernet provides, there'll be in various variants, right? You can call that is an 10 base 5, 10 base 2, 10 base t, 10 base f as well. Okay, as I said already, you can multiply this with there'll be the 100. You can go up to the distance of there'll be an 500 in case of 10 base 5. In case of 10 base 2, you can go up to there'll be an you know uh, 200 meters. In case of 10 base t, you can go for what do you call, there'll be an different channels here. That is in 10 base f is there'll be an fiber channel. Okay, so you can make use of there'll be an fiber cables as well, rather than there'll be the ethernet cable, right? And also in case of there'll be in 10 base t, it may be full duplex communication as well. Yeah, if you look at all these right cable variants which you use, it all of them you can categorize it based on these parameters, which includes BDM, which uses, then we have a signaling, the kind of signaling what it has, then topology, okay, what it uses basically, and the number of nodes which you can connect it in each case. Okay, if you look at, there is a 10 base 5 medium is coaxial, 10 base 2 is also coaxial, right? And in case of 10 base t is an UTP is unshielded twisted pair, that is UTP is an unshielded twisted pair. And 10 base f is 250 nm, it's a nanometer, there is a fiber. Okay, that is the kind of uh, specifications we use it in case of the 10 base f. Yeah, signaling, in case of 10 base 5, signaling is baseband, 10 base 2 is also baseband, 10 base T is also baseband, and 10 base F is Manchester signaling. Right. So then topology is in the first two, it is in bus topology. In the next two, right now, segment, it is in star topology. Then nodes, the number of nodes which you can connect in case of 10 base 5 is 100, in 10 base 2 is 30. Okay, unshielded twisted pair, you can go, there will be an as many here, right now. And in case of 10 base 3, 10 base F, it is in 33. So these are all some of the specifications what you're supposed to right now know about, as and when you want to design your local area networks using the 10 Mbps right Ethernet specifications. because right, if you want to design a local area network at right college level or at your office, then with the present context, 10 Mbps is good enough, or do you really require there will be more than that? That you need to think about it. Okay, but for a smaller and where right less number of users are communicating with one another, then 10 Mbps may be sufficient. But since the rapid growth is happening with respect to internet services and applications, 10 Mbps may not be sufficient. Hence, we go ahead with there'll be a fast Ethernet with the speed of right 100 Mbps, right? So what will happen in case of there will be a 100 Mbps fast Ethernet? You can just observe it. Some of the points relating to that now. Yeah, it uses 802.3 MAC protocol again and a frame format. Even your 10 Mbps also uses the same thing, right? Then 100 base X use a physical medium specification from FDDI. Okay, that's a fiber distributed data interface, right? Then two physical links between there will be the nodes is possible. Then transmission and reception is happening very smoothly in case there will be 100 Mbps, because right the speed increases from there will be 10 Mbps to 100 Mbps. Then 100 base TX uses STP, right? STP is here shielded twisted pair, or there'll be a Cat5 UTP unshielded, there'll be a twisted pair. I mean, we're talking about the kind of cabling what we use in case of there'll be a 100 base TX here. And sometimes it may require there'll be the new cable as well. In the sense, when I'm talking about a new cable, you can also look for the other kinds of cable, which includes Cat6, Cat7, right? The cable. Don't go lesser down about Cat5. Then we have 100 base FX users. There will be an optical fiber, okay, instead of UTP and STP. You can also look for there will be an optical fiber cable in case if there is an FX. 100 base T4 can use there will be an Cat3, that's a voice grade UTP cables. Uses 4 twisted pair lines between there will be the nodes, and data transmission uses 3 pairs in one direction at a time. Then it can be designed with star-wide topology, similar to the LBN 10 base T. So the whole idea is that you have to understand, some of the variants of 10 Mbps, 100 Mbps, right? No, the kind of cables which we use in case of 10 Mbps, 100 Mbps. Similarly, you should also understand there'll be an what do you call, there'll be an high speed Ethernets as well. Okay, one is an Ethernet, that's an 10 Mbps, a fast Ethernet that is an 100 Mbps, and the next variant is going to become, there'll be an high speed Ethernet that is going to become 1000 Mbps. And one more variant which is available in it, that is what is to be called as gigabit Ethernet, where that is the speed of that is 10 Gbps. Okay, we are moving from Mbps to Gbps. Okay, yeah. That is right. I was mentioning about these things right in the previous slide. The same thing is repeated here, and also we have mentioned here the kind of cables what we use it in each case. That is an 100 base TX. The cabling is 2 pair. Sorry, that's 2 pair STP cable, and 100 base FX 2 pair Cat5 UTP cable. 100 base T4, it's in 2 optical fiber cable, or it may be in 4 pair Cat3, 4, 5. These kinds of there'll be in cable. You can make use of it. And this is the signaling we use in each case. There's an MLT3. Okay, that is an here you have, there will be an 4B, 5B, NR, ZI, signaling coding technique, right? In case of there will be an 100 base T4. So yeah, similar to that, we have 100 base X media in detail. Once again, the same thing are going to be repeated. Okay, I'll just skip this slide, 100 base T4 medium. I think overall I have mentioned that the different types of cabling techniques which we use in case of 100 base right fast Ethernet. You can just refer these slides for more details as well. Yeah, this is what is the overall summary or the flow diagram of your fast Ethernet, right? With relating to there will be 100 base twisted pair Ethernet cable here. So wherein we have 100 base T, which is further classified into 100 base X, 100 base TX, and 100 base FX, where the different cabling we use in each case, are mentioned here. Okay, one is 2 category 5 UTP cable and 2 STP cable. So I reiterate here, when I'm talking about 2 category 5 UTP cable, it's an unshielded twisted pair. STP cable is shielded, there is a twisted pair. 100 base FX, where you have there is a 2 optical fiber cables. 100 base T4, it is a 4 category 3 or category 5 UTP cable. I think to understand how the structure of each cables, right, you can just Google it, some of the things, and you can know it. Otherwise, as and when you visit right now a lab of where you are working, right now you can observe it. Or even if you come to the college once, right, definitely we can have one kind of practical demonstration how really you can make use of these kinds of cables to connect your devices together for constructing a local area network. And maybe you may be knowing it how to design a local area network by taking different devices with a switch, and you can configure your port to connect your right devices. However, right, how do we do the same thing right using there'll be a high speed data rate links? That is what is we need to think about it. And also you have to observe, right, what's going to happen with respect to different links, whatever you use it. Let us say you make use of there'll be an Ethernet. What's going to happen? Observe it. Use fast Ethernet. Observe the results. Okay. Then similarly, go for there'll be an high speed Ethernet. Observe the result. Use fiber channels. Observe the result. Hence, you can come to a conclusion that so as and when you move on to there'll be an high speed data connectivity links, how your network or network speed is going to be improved in case of there'll be data communication. That's the whole idea. That's where high speed networks plays very key role in data communication and connectivity among there'll be more and more number of devices. Yeah, this is the another aspect of operations relating to the connectivity factor, that is in full duplex operations. Earlier we were talking about only there will be an off duplex, right? Nowadays we talk about there will be a full duplex. There will be what's going to happen in case of there is a full duplex, where transmission and receiving operations is going to happen. There will be simultaneously. Okay, and with there will be a high speed. Okay, when I say there will be a high speed, you need to have such kind of data connectivity with your network. Otherwise, it is not possible during that. Okay, so again, the moment if I talk about high speed local area network design aspects, you should able to identify the hardware, software, protocols, right, requirement, and the kind of cables requirement for the connectivity purpose with one or more number of devices. Yeah, it is not just there will be in full duplex operations. You can also think about mixed configurations. Sometimes again since you are going to construct there will be an new setup, you always look for there will be an advanced technology. But however, networks may be available already with your organizations with the different speed. It may be 10 Mbps, 100 Mbps, or even there will be 1000 Mbps itself. So then we have there will be mix and match in your configuration setup. Hence, you need to have these kinds of networks to be connected with one backbone network, where the backbone LAN network is going to support all of them, right? without any glitches. Like that, you can think about it. That's where we are talking about here, right? 100 Mbps backbone LAN to support there'll be 10 Mbps hubs. Stations attached to 10 Mbps hubs using there'll be 100 base T, cabling as well. Hubs connected to switching hubs using there'll be 100 base, T. Then support 10 Mbps or as well there'll be 100 Mbps. There'll be speed connectivities. High capacity workstations and servers attach directly to 10, 100, switches, 10 slash, or there'll be 100, switches. Switches connected to 100 Mbps hubs using there'll be 100 Mbps links. 100 Mbps hubs provide there'll be building backbone networks basically connected to router providing a connection to wide area networks. So the whole idea is that right now you can always look for different high-end right capability switches to handle these kinds of there'll be a situation where you have there'll be more and more number of there'll be ports in your switches to have right the connectivity of such number of nodes in your high-speed local area network. Having said all these things, right, you should also look for some of the characteristics of there'll be an high-speed LAN. Okay, at the left-hand side, you can observe it. Some of the properties we look for it. One is a data rate. You can just see in case of fast Ethernet, the data rate is 100 Mbps. Gigabit Ethernet is on 1 Gbps, right? It also go up to there'll be 10 Gbps, 100 Gbps, gigabits per second, right? In case of fiber channel, it is on 100 Mbps, and it may varies 100 Mbps to 3.2 gigabits per second. Whereas in case of wireless local area network, okay, speed is now 1 Mbps to that been 54 Mbps, right? That's the data rate. You can observe it even right here. We don't have there'll be an Ethernet, right? When I say there's an Ethernet, your data rate, right? Switched from there'll be 10 Mbps to there'll be 100 Gbps in case of there'll be gigabit Ethernet. So the present day, right? Local area networks are designed with gigabit Ethernet. Even right, we go ahead with there'll be fiber channels. Right, local area networks links, okay, where the speed is very high basically. Yeah, then we have a transmission media, okay, that is UTP STP optical fiber in case of fast Ethernet. Yeah, in case of gigabit, that is an UTP shielded cable optical fiber. Fiber channel is there is an optical fiber and coaxial cable STP. I think I'm not going to talk about once again what is STP is here. That's right now. Then the wireless LAN is going to become 2.4 gigahertz to there'll be 5 gigahertz, right? Microwave. Then access mode is here CSMA bar CD protocol. Gigabit Ethernet is switch protocol, right? In fiber channels also it is unswitched, whereas in case of wireless LAN it is in CSMA / there is a pooling protocol. And supporting standard of fast Ethernet is 802.3. Gigabit Ethernet is 802.3, whereas fiber channel is fiber channel association, and your wireless LAN is IEEE 802.11. Okay, so this is a very important slide to understand various right configurations or specifications relating to right the different technologies, whatever we use it to build your local high-speed local area networks, irrespective of your locations. Yeah. Again, having said the characteristics of right various technologies, right, you can also understand some of other variants of Ethernet configuration relating to 10 Mbps, and there'll be 100 Mbps. I think I have already shared a lot of details. I'll share the slides with you all. You can just refer some more points relating to this. I'll skip this slide. when it comes to the right now maximum segment length of a cable which you use with respect to different you know transmission media, we have the details here. Okay, 10 base 5. The topology is bus and maximum segment length you can go up to, there will be 500 meters, right? The transmission media here is there is a coaxial cable, right? 10 base 2, it's in bus topology, 185 meters. You can just multiply that with 100. You can also go further between 200 meters. 10 base T, 10 base T is again, it uses that being star topology right now. Then 100 meters distance, that is the maximum distance, and the transmission media is twisted pair. Yeah, the list goes on here, right? You can go through all these details once again to know there will be more usage with respect to maximum segment length, which we use as and when you use, there will be different cabling structures. Yeah, then when it comes to gigabit Ethernet configuration, wherein we can also look for different protocols. These protocols are introduced by the IEEE, right? We have 802.3, 802.3U, 802.3Z, okay, and 802.3AE, okay, where in case of each standard, we have there will be a corresponding, there will be the data rate. 802.3 uses there will be 10 Mbps and the corresponding media type, and 802.3U, it's 100 Mbps, again corresponding cabling length and its length. And gigabit Ethernet, right, 1000 Mbps, right, and 10 gigabit Ethernet is there will be 10 Gbps, okay, 10 gigabits per second, and corresponding there will be media type and the maximum distance, right, coverage as and when you want to design your high speed local area networks. Yeah, slowly as and when we right now move on to, there will be various technologies we used in each case. We should also think about right now always how fast Ethernet and fast Ethernet is going to be categorized, and however, right, how your gigabit Ethernet and 10 gigabit Ethernet is going to be categorized. Okay, if you look at these two, gigabit Ethernet and 10 gigabit Ethernet, right now. The corresponding points gives you there will be more details, right? Gigabit Ethernet uses CSMA BOS CD plus it's a full duplex communication. Okay, 10 gigabit Ethernet is a full duplex only, right? Gigabit Ethernet is leveraged for fiber channel, PMDs, whereas in case of 10 gigabit Ethernet, new optical PMDs are going to be used. And in case of gigabit Ethernet, it is reused with 8B, 10B coding, whereas here it is in 64B / there is in 66B coding technique, right? These are all signal coding technique, right? What we are now observing it here. Then optical copper media, okay, that is in case of gigabit Ethernet. Here it's an optical media only. Then it supports LAN to 5 kilometer. It supports there is a LAN to there will be 40 kilometers. Okay, see the distance coverage in case of there will be 10 gigabit Ethernet, because it is possible because of there will be the very high end speed what you have it here. Okay, so certainly that is what is the advantage you have it with respect to your gigabit Ethernet. Yeah, if you observe gigabit Ethernet configurations, right, this is one simple network model wherein you can have these devices in your high speed local area network structure, and you can configure each one of them according to the devices whatever you use it with the corresponding, there will be the port numbers, and ensure that the data communication is going to happen from one end device to the another end device. So you can have, there will be different right switches. The switch may be 10 Mbps, 100 Mbps, 1000 Mbps, or it may be even 10 Gbps Ethernet switch, right? So look at this, right? the number of set of devices are going to be connected, right? Maybe you have, there'll be 18 students, all 18 nodes are going to be connected, right, to your, uh, 100 mbps switch, okay, ethernet switch, wherein you are trying to make use of, there'll be different cabling structure, maybe a fiber, or it may be, cat 5, cat 6, whatever it's, so to the another kind of, you know fiber, switch here, right? Then you may be able to communicate via network to the another end of your devices, okay? So you can uh, construct it in a very simple manner, or you may have it, there will be more and more number of, networks as well, when you talk about your devices. Yeah, this is one right complex scenario wherein as and when you started using, there will be more and more number of devices with the different working groups. What is going to happen it, right, with respect to high speed local area network? You can observe from this particular diagram that, right, initially you may have, there will be different work groups with a different local area network, which are connected with 100 to 1000 mbps switches, I mean hubs here, right? Even your servers are connected to this, right? So on the left hand side you can observe that the same kind of scenario, you can observe it on the right hand side as well, okay? But however, right, all of them are going to be, right, connected via, there will be a very high end speed switching hub, that's an 1 gbps, right, where 1 gbps switch hub is further connected to your centralized servers. That's what I said. This is some kind of mix match configuration of your fast Ethernet, high speed local area networks, where you can think about, there'll be a fast Ethernet, right? No, gigabit Ethernet, or even you can go for, there'll be a high speed gigabit Ethernet to connect, your nodes and servers together for better, right, data communication and more and more reliability. Okay, that's the whole idea, is that, right? I think these are all the aspects which you're supposed to be understand, right, in terms of okay, gigabit, what do you call, there'll be an emergency, right, of high speed local area networks, gigabit Ethernet, fast Ethernet, 10 gigabit Ethernet, whatever it's. So if you have any questions, you can ask me so that I can answer you. Otherwise, I'll move on to the next point. Hello? Hello?
Yes, sir.
Do you have any questions here? Hello?
Yes, sir.
No? Yeah, I'll move on to the next right now topic, that is wireless LANs, right? I mean, sorry, that's a fiber channel. Let's move on to the next topic. That's a fiber channel. I'll stop sharing this particular slide and I will upload the another one. One minute. Are you able to see? Hello?
Yes, sir.
Yeah, it's a fiber channel slide. Can you able to see it?
Yes, sir.
Okay. Yeah, let me right now, ask some one or two questions to know about your understandings here right now. Yeah, Sneha, could you say, right, what are your understandings from right now fast Ethernet Ethernet, fast Ethernet, gigabit Ethernet, right, and other variants of technologies, whatever we have discussed. Yeah.
Sir, gigabit Ethernet, it is full duplex and also CSMA CD, and it is used in optical media, and also it support LAN to 5 kilometers.
Okay.
Sir, um, then 10 gigabit Ethernet, it is up to support up to 40 kilometer.
Okay.
Then it is for optical media only. The,
Fine. What about Bhavtarani? Hello, Bhavtarani.
Yeah, sir.
Yeah. What is your understandings from the whole discussion, whatever we had just now?
Yeah, so basically about the speed, the bandwidth.
Okay.
Yeah.
Yeah. What about Tejaswini? Hello, Tejaswini. Yeah, I'll. I think no response from Tejaswini side, right?
Hello.
Yeah. Hello.
Hello.
Yeah. Are you listening, Tejaswini? Is it audible?
Hello.
Is it audible? Hello. Yeah, I'll move on to the next, presentation, right? That is fiber channel. Okay. I'll just maximize my screen sharing here. Yeah. Fiber channel is a high-speed network technology used to connect servers to data storage area networks. It's a technology handles high performance disk storage for applications on many corporate networks, and it supports data backups, clustering, and replication as well. Okay, because nowadays, right, wherever you go, most of them they use they'll be in fiber channel. Okay, rather than that, right, STP, right, and UDP cable connectivity links. It's a high-speed networking technology primarily used for transmitting data among data centers, computer servers, switches, and storage at data rates up to 128 Gbps, gigabits per second. So what I'm trying to reiterate here, how you are moving on from 10 Mbps speed to right no 10 Gbps speed in case of there will be an right a gigabit Ethernet. Okay, whereas when the moment you make use of there will be in fiber channel, you can utilize the data transfer rate up to there will be in 128 Gbps. Even at present scenario, we have more than that as well. Yeah, it's a high-speed data transfer protocol running at 1, 2, 4, 8, 16, 32, 64, and 128 gigabit per second rates, providing in order, okay, that is, losslessly delivery of raw block data. Okay, there won't be any, loss in your data. Okay, lossless delivery of right data. That's the reason, you know, most of them, they prefer there will be a fiber channel nowadays for your connectivity among your devices. Yeah, it is considered a lossless protocol. You know, fiber channel switches are lossless, while Ethernet switches may be at the risk of dropping a frame right during your data transmission. Hence, you know, we go ahead with a fiber channel technology. Fiber channel switches, they can operate smoothly without dropping a single frame, and all the data frames are transmitted in order. That's what I said, you know. It all depends upon the speed, whatever you use it, right? So starting from 1 Gbps to, you can go ahead with 128 Gbps, depends upon your requirement, right? You know, optical fiber transmits data faster than there will be the copper Ethernet cable, and has the potential to be right, you know, incredibly fast compared to your Ethernet technology. A single optical fiber strand has been shown to transmit a data at a rate of 100 terabits per second. Okay, you can have some topology structure, you can observe it at the later of my discussion. Fiber offers speeds up to 10 Gbps, symmetrical upload and download bandwidth. Cable internet is slower at the same time, though it offers a broadband speeds what that meets the most small and medium size business as well. Okay, I think I'll just you know use this is one kind of structure what you have it. Okay, right. I think you can observe it. Okay, how your fiber channels are used to connect right your network resources, okay, with different storages, right? I think just a minute. Yeah, and you can listen to this right now audio right for 2 minutes, 2 to 3 minutes, I think.
In the Computer Storage Basics video, we said that a Storage Area Network, or SAN, is a computer network designed to deliver block-level storage to computers that are not directly connected to the storage devices or drive arrays. The storage in a SAN is not owned by one server, but is accessible by all of the servers on the network. This SAN storage is divided into logical storage pools or volumes that can be assigned to particular host servers. SAN interfaces include Fiber Channel, iSCSI, and Fiber Channel over Ethernet. This video will focus on Fiber Channel. Fiber Channel is a high-speed networking technology primarily used for computer storage applications. Most of the larger data centers that have implemented SAN technology have implemented Fiber Channel technology. These enterprises typically demand proven technology, need high bandwidth storage solutions, are willing to invest in the hardware required to meet their performance and reliability needs, and typically have full-time staff dedicated to storage management. Many of these data centers continue to invest in fiber channel storage solutions and plan to do so for the foreseeable future. Fiber channel technology was introduced to the market in 1997 at 1 gigabit per second and has doubled in speed every 3 to 5 years up to the current 32 gigabit fiber channel technology available today. Although each generation of fiber channel was introduced into the market in the years shown here, widespread industry adoption sometimes began later. Generally speaking, fiber channel is backward compatible with the 2 previous generations. This means that 32 gigabit fiber channel switches, Host bus adapters and optics are backward compatible with 16 gigabit and 8 gigabit equipment. When using fiber channel, there are three basic ways to connect servers, which are known as initiators, to storage, which are called targets. These are direct connect, arbitrated loop, and switched fabric. Switched fabric is the most commonly deployed, while arbitrated loop is becoming less common. Let's examine some of the components used for fiber channel technology. Fiber channel host bus adapters, referred to as HBAs, connect devices to the fiber channel network or another fiber channel device. Fiber channel storage arrays can be composed of hard disk drives, solid state drives, or a combination of the two. Storage array vendors are beginning to make the transition from 16 gigabit fiber channel to 32 gigabit fiber channel. Fiber channel switches are used to direct traffic into a fiber channel fabric. Backbones, or directors, form the central core of an enterprise fiber channel fabric, and edge switches are the local attach points into the fabric. Enterprise fiber channel fabrics often have redundant components in order to provide high availability.
Yeah, hello. Hello.
Yes, sir.
Yeah, I mean that's one very short video play, right, relating to the Libyan fiber channel. You have there'll been lot many, right, no right videos relating to fiber channel or maybe an Ethernet as well. You can just watch some of the things to understand how these things are going to be connected with right various other network resources, right. I will move on to the next topic, whatever I'm just discussing it. Okay, you can just observe it. Yeah, will you able to see the slides?
Yes, sir.
Yeah. I think we have just seen. I mean, this is how right fiber channels are used to connect your other computer network resources, which includes your servers, nodes, because many nodes and servers are placed in a rack wherein right most of the time we make use of the bin fiber channels to connect right these devices. Yeah. When we go ahead with a fiber channel, we have some points how your fiber channels are going to be connected with respect to IO channel, network connection, and other aspects. With respect to IO channel, you can have a direct point-to-point or a multi-point communication link. So that means you can think about there being fiber channel connectivities. Hardware-based IO channels, right? When you want to have, there will be an high speed data communication, data rate, very shorter distances, right, or user data moved from source buffer to destination buffer. In all these aspects, definitely you can look for the bin right fiber channel. Then in case of network connection, interconnected access points, a software based protocol, then flow control, error detection and recovery applications, and end systems connections in such right aspects you can think about right fiber channels. Yeah, coming to the technology wise, it's a channel oriented. In case of channel oriented, when data type qualifiers for routing a frame payload, link level constructs associated with IO operations, a protocol interface specification to support existing IO architectures, where right. The simple example to talk about is SCSI, that is a small computer system interface, right. Connectivity you would like to establish it, then you can think about your fiber channel. The network oriented, wherein you have full multiplexing, right, between multiple destinations, peer-to-peer connectivity and internetworking to other connection technologies, right? You can look for a fiber channel. Having said that, we have some requirements in case of fiber channel, connectivity, where, right, fiber channel provides full duplex links with 2 fibers per link only. Okay. Then the speed is 100 Mbps to 800 Mbps on a single line. Whereas in case of full duplex, it varies from 200 Mbps to 1600 Mbps per link. Okay. It can go up to, there will be a 10-kilometer distance, right? You can also have, there will be small connectors to connect your requirements. High capacity utilizations, distance insensitivity, right? Greater connectivity than existing multi-drop channels. Broad availability, that is with respect to standard components, right? I mean, wherever you come across these kinds of, there'll be an requirements and capabilities. Always you can look for, there'll be an fiber channel, right, with different speed range as well. Yeah, multiple cost performance levels. Small systems to, there'll be in supercomputers. Then carry multiple existing interface command sets for existing channel and network protocols. Uses generic transport mechanism based on point-to-point links and a switching network. Then supports simple encoding and framing scheme. In turn, supports a variety of channel and network protocols, right? In all these conditions, you can look for your fiber channel requirements. Yeah, this is talks about. Hello. Yeah, any issues? Hello.
No, sir.
Yeah. Yeah. We have certain elements with respect to fiber channel. We have summarized here, and also you can observe those things with respect to this diagram as well. Okay. There's an end system nodes, right? Obviously, you can call these things our end system nodes on either side. Switched elements, right? The switched elements are inside whatever you have, right? The network or a fabric. Then communication across point-to-point links. Okay, so you are identifying these are fiber channel, elements basically. We have already mentioned some of the aspects of fiber channels. Right, it provides range of options for physical medium, the data rate of medium, and topology of network as well. Okay, shielded twisted pair, video coaxial cable, and optical fiber. You can just think about it as and when we use your fiber channels, wherein the data rates speed varies from 100 Mbps to 3.2 Gbps, right? And point to point from, there'll be in 33 meters to, there'll be in 10 kilometers. So in the sense that, let us say, you can also look for, right, fiber channel, shielded twisted pair, video coaxial cable, and optical fiber, as and when you want to have a connectivity with your nodes to, there will be in switches or servers, whatever it's so. Yeah, I mean, this is the framework, right, of your fiber channel. Okay, which is identified with 5 layers, starting from, there'll be an fiber channel 0 to fiber channel 0, fiber channel 1, 2, 3, and 4. Totally 5 layers you have it here. So you can observe it at the fiber channel 0 level, where you have, there will be different data bitrate speed. Okay, starting from, there will be 133 Mbps to, there will be 1062 Mbps. I mean, even though we have 133, you can also have, there'll be different speeds as well. So it doesn't mean that you have to make use of only those things. It depends upon, your requirement and what you have, what you're using into your network, that matters. Again, fiber channel 1, where you have, there'll be an encoding and decoding, deployment techniques. Then fiber channel 2, wherein you have framing protocol and flow control monitoring as well, right? That is at layer 2. And at the layer 3, we have, there'll be an common services, okay, which you are trying to do it with respect to your requirement. And at the channel 4, right, wherein you are looking for, there'll be different what do you call, right, bus structure, or network, whatever we use it right now. You starting from IPI, SCSI, or HIPPI, SBCCS, 802.2, IP, ATM, and even you can add some more also at FC4. I mean, this is how, right, your fiber channel frame is categorized. It all the details are available here. I think I have already explained each one here, right? I think you can just elaborate it more in details. Coming to the fiber channel 4 mapping, right? That is a mapping of channel and network services onto a fiber channel, which includes, right, whatever I just mentioned. Yeah, coming to fiber channel fabric, where you can call, it's a general topology called a fabric or a switch topology. Arbitrary topology includes at least one switch to interconnect number of end systems. Okay, may also consist of switched network. Some of these switches supporting end nodes and routing transparent to nodes. Each port has unique address. When data transmitted into fabric, edge switch to which node attached uses the destination port address to determine location. Either deliver frame to node attached to same switch, or to transverse frame to adjacent switch to begin routing to remote destinations. I mean, we're trying to talk about how your network elements are connected with one another, and how, right now, routing right happens among the different nodes in a fabric kind of communication. Yeah, then we have several advantages when it comes to fabric, right? We have certain benefits of it. That is scalability of capacity. I think you understood, because you have noticed that the way different capacities, that's in data rate speed here. Yeah, as additional ports added, aggregate capacity of a network increases, right? Minimizes congestion and contention when you use, there is in fiber channels. Increases, there'll be the throughput compared to, there'll be an Ethernet technology, right? It's a protocol independent, distance insensitive. Okay, these are all you can add it with respect to, right now, what do you call, there'll be scalability of capacity. Then switch and transmission link technologies may change without affecting your overall configuration, right? Burden on nodes are going to be minimized, right? Fiber channel node responsible for managing point-to-point connection between itself and there'll be in fabric. Fabric is responsible for routing and error detection as well. Yeah, to work on, there'll be in fiber channel, you can always look for, there'll be in different topologies, right? Which includes point-to-point topology, right? Where you have only two ports directly connected with one another. Okay, no routing is required in case of there is a point-to-point topology. Whereas in case of arbitrated loop topology, you have simple low-cost topology. You can go up to 126 nodes in a loop. Operates roughly equivalent to the Bilbin token ring topology here. Topologies, transmission media, and data rates may be combined in this particular case. Yeah, this is right. 5 applications of fiber channel, right, connectivity. Okay, you can just see that, right? 5 applications. Look at the top on the left hand side, linking high performance workstation clusters to your fiber channel fabric. That's one application. When it comes to the second one, connecting mainframes to each other, right now, see here, see two mainframes are connected to each other, and also, right now, these mainframes are connected to your fiber channel switch fabric as well. Okay. At the bottom, you have, there'll be the third application where giving server form high speed, there'll be in pipes again. Okay. So rather, I could say all your servers are connected to your fiber channel switch fabric. So then when it comes to the right fourth one, clustering disk right establishment, right now, you can observe it on the fourth application, right? And lastly, you have the fifth application that's in linking LANs and WANs to the backbone networks. See, there are so many LANs, right, which are connected with one another to your backbone switch, right, in turn, which is connected to your fiber channel switch fabric. So the whole idea is that, right now, you can understand that, right, how fiber channels are going to be used to connect your network resources with right the establishment or design of your network right configurations, and how you can also scale up that. Let us say, even though you have at the fifth application only right bus topology, ring topology, and ATM local area network, you can also scale up that to one more network, right, with connecting to your switch fabric, right? So you can scale up as per your requirement. Okay. So right, however, as and when you use your fiber channel, you have to understood some of the good parts or good factors of the LBN fiber channel. Yeah, these are backed by the LBN Fiber Channel Association. Interface card for different applications are available, right? Most widely accepted as peripheral device interconnect. Then, to replace such schemes as SCI, then technically attractive to general high-speed local area network requirements, then must compete with Ethernet and ATM LANs, okay? And cost and performance issues should dominate the consideration of these competing technologies as well, okay? So these are all some of the other aspects of your, right now, fiber channel, right? I think I have already, mentioned. Yeah, I have taken one more video here, right? I think you can watch it in the next class probably in detail with respect to this. Again, it talks about, okay, how you were, I'll just showcase it here. Yeah. Maybe it is 29 minutes. I'm not going to, play this. You can refer it right now, as and when you want to study something related to fiber channel.
In this lesson, we're going to start covering our SAN protocols. And the best one to start with is the original SAN protocol, which was fiber channel. Before we start getting more in depth on fiber channel flow, let me give you some general SAN terminology. First, we have a LAN. LAN is a logical unit number. That represents a disk that will be presented to a host. So the client connects to its LAN, it sees the LAN as if it was a local hard drive. LANs are specific to our SAN, not our NAS protocols. Other terminology, the client is known as the initiator and the storage system is known as the target. Fiber channel is the original SAN protocol and it's still very popular today. It uses dedicated adapters, cables and switches and is different than Ethernet at all layers of the OSI stack, including the physical level. So you can't use an Ethernet network card or an Ethernet switch for fiber channel. It uses dedicated fiber channel infrastructure. This is different than our NAS protocols, which run over Ethernet. The FCP, Fiber Channel Protocol, is used to send SCSI commands over the fiber channel network.
ಇಲ್ಲ ಲೈವ್ ಏನೇ ಕೊಡ್ತೀನಿ ಎಲ್ಲ ತೆಗೆದೆ ಹೇಳಿದ ಎಂಡ್ ಅಲ್ಲ 20 minutes. Hello. Yeah, I'm going to play the video again during the next session for a few more minutes. I think I'm going to share the slides with you all, right? You can also watch the video to understand more of insights of the fiber channel, okay, so that you can get good knowledge right with respect to fiber channel, right? Is it clear? Yeah, do you have any questions further? Hello?
No, sir.
No, sir.
No. Fine. Right. I think I've discussed some of the aspects of the fiber channel fabric requirements, advantages. Okay, how the fiber channels are going to be used. Also, right, various topologies which you use with respect to fiber channels, along with the design configuration of fiber channels with various applications, right? And I'll further talk about various data transfer rate we use with respect to fiber channel in detail, and how the fiber channel is going to be data rate speed is going to be varied with respect to Ethernet speed, in detail in the next class. Okay, right. If you have any queries, you can ask me. Right. Otherwise, I'll stop the stage. Do you have any questions? Hello.
No, sir.
Okay, so I'll stop the stage, right? I think you need to switch over to for the another class. Okay, right. You can start attending. Right, the another class we'll join again at 11 o'clock tomorrow. Right?
Okay, sir.
Okay.
Okay, fine.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Thank you. ಕಡಿಮೆ ಆಕ್ಚುಲಿ ಮಾಡ್ಕೊಳ್ತಾ ಇದೀನಿ. ಅವರು ಈ ಫ್ರೈಡೇದು ಒಂದ್ ಸ್ವಲ್ಪ ಇದಿದೆ.
ಇಲ್ಲೊಂದು ಎಕ್ಸೆಲ್ ಶೀಟ್ ಇದೆ ನಿಮಗೆ, ಗೂಗಲ್ ಎಕ್ಸೆಲ್ ಶೀಟ್
ಎಲ್ಲಿದೆ ರೀ ಮೇಡಮ್? ಅದು
ಮಾಡ್ಕೊಳ್ಳ ನಿಮಗೆ
ಮಾಡ್ಕೊಡಿ.
ಮಾಡ್ಕೊಡ್ತೀನಿ ಸೆಕೆಂಡ್. ಆ ನಿಖಿಲ್ ಬಗ್ಗೆ ಮಾತಾಡಕ್ಕೆ
ಹಾ ಬಂದ stop presenting. Just close this. Stop recording.